When cognitive scientists began to compare performances on individual selection tasks across different cases, what they discovered was a pattern that we'll probably recognize. So if we rank those selection tasks from ones that are less difficult, where we're more likely to get the correct and complete answer, to ones that are much more difficult, where we're less likely to get the correct and complete answer, then we have a familiar content effect that we saw in our general discussion of deductive inferences with our native System 1 capacities, namely selection tasks that involve familiar content with objects, relations, and events with which we had some experience. Those were a little bit easier than selection tasks that involved unfamiliar content, that involved objects, relationships, or events with which we had little familiarity. So there was that distinction. But that distinction was really swamped by that difference between deontic schemas, that is, selection tasks that involve relationships between conditions and permissions, and conditions and obligations. So permission obligation schemas, those were just much, much less difficult. We were much more likely to get the correct and complete answer than we were for any other kind of conditional in these selection tasks. So that strong distinction between deontic schemas, permission obligation selection tasks, and all other selection tasks prompted some researchers to hypothesize that we have a context-dependent inference strategy that is triggered by those deontic cases, by permission obligation, by social cognition. And that's what drives our successful or more successful performance in those cases, as opposed to our general relatively poor performance on the other instances of the selection task. Why might that be? Well, some cognitive scientists, for instance, psychologists up at the University of California, Santa Barbara, hypothesized that that context-dependent inference strategy emerged as a result of our evolution during that 4.4 to 7 million years of human and proto-human evolution, where we lived predominantly as hunter-gatherers in small social units. And the hypothesis is this, that during that relatively long period of time, our existence, our hunter-gatherer existence, required us to depend upon a cohesive and coordinated social hierarchy and relationship with our other group members. And so part of what we evolved to do was to maintain the cohesion and the coordination between other members of our social groups. And so they hypothesize that because we need to do that, we need to be able to solve inference problems that involve conditional relationships. If I do this, will it upset my social group? If I do this, am I going to cause disruption? Am I permitted to do this? If I do this, will people be fine with it? And so because I need to be able to make those inferences, and I need to be able to make those inferences before I actually perform that action, before I cause the harm or not, I need to be able to make those conditional inferences in permission and obligation cases in ways that I don't for other circumstances. And so they hypothesize that it's my need to maintain a cohesive and coordinated social group that has these social hierarchies, these permission and obligation structures, these relationships between one another, that I have evolved to be able to make those conditional inferences that involve deontic relationships. So now we're in a position to really see a number of different examples or illustrations of contextualization in our native deductive inference capacities. So we've seen limitations involving the content, both in terms of the amount of information that we're able to process and in the complexity of the information that we're able to process, even in our native or System 1 deductive formulation and evaluation. we've seen that our beliefs will introduce context that can bias us in our evaluations of the goodness or badness of inferences based upon whether or not we find those conclusions or the inferences results to be believable or not. We've also seen that just the introduction of a little bit of complexity in the form of that negative conclusion bias can introduce enough complexity to undermine performance substantially. And finally, we've seen that we exhibit a differential performance on deontic versus non-deontic conditional reasoning tasks. In the next lecture module, we'll turn our attention to another example of a context-dependent inference strategy, in this case, one that involves our native inductive inferential capacity.